Wanted to do one more example here where you can think of the continuous payment stream as the sum of, or difference in this case, of two different payment streams. So again, pause your video, get a chance to write it down, and then we'll have a chat about it. All right, so for this one, we've got a 10-year annuity making continuous payments. We notice that in this case, the annual rate of payment is 30 minus 3t. So we could just go ahead and straightforward use the formula that we talked about before with the integrals of each of the pieces and go through it and do the problem. But again, I wanted to show you a little bit different way to look at it and thinking about it in chunks, if you like to think about it that way. They tell you that the time's measured in years, the annual effective interest rate is 5%, and we're going to calculate the present value. Again, since we've got continuously varying payment streams here, we need to change that effective interest rate, annual effective interest rate, into a force of interest. So for force of interest, again, we use this nice formula. The e to the delta is 1 plus I, and we get delta is, well, a little 4.87 and change percent here. All right, rather than using the integration formula, which you could absolutely do, and I would encourage you to do it as practice just to see that you get the same answer, we can actually think of this as a combination of two different annuities. You've already had this concept looking at increasing annuities back in Chapter 8, where you broke it into a level annuity and an increasing part, or a level annuity and a decreasing part. And I want to just kind of go through an analogous process here that we could do for continuously varying payment streams. So we notice that we've got a level part of 30, and we've got this, what we just talked about last time in the last video, that continuously increasing piece of the 3t. So if I want to calculate it in two different pieces, we can. So we already have a formula, a nice formula for the level annuity part. The level annuity, again, for the present value will be this 30A bar, A angle 10, 4.879%. Our formula in that case is the 1 minus V to the N. That's why I've got the 1.05 to the negative 10 here, over the force of interest, over the delta. And for that piece, we see that the present value is 237.40. For the increasing part, now in the last video we used the integration formula. They actually go through in the textbook and derive the formula for a continuously increasing annuity. And that formula looks a lot like your continuous annuities that you talked back in Chapter 8. So let's talk about this one small difference between the two formulas. The notation here is the bar completely over the IA part. So it's 3 times the IA bar of 10 angle 4.879. If you remember back in Chapter 8, your formula in the top involved the annuity due of a payment of 1. When we do a continuously increasing annuity, instead of annuity due in the formula, it's a continuous annuity in the formula. The same formula learned back in Chapter 8 for that. So the formula is identical except for using continuous annuity rather than annuity due. It's still that continuous annuity, angle 10, minus NV to the N. So 10, 1.05 to the negative 10 divided by delta. If you go through that, you get 109.08. And if you're an astute viewer of these videos, you'll notice that that's the exact same thing we got in the previous video, doing it with integrals. So anyway, now that we've got a combination of those two things, notice it was 30 minus the 3t. So to find the present value of the annuity, we will subtract the two values to get a present value of 128.32.